Your untied lace isn't a mistake, it's a physics experiment. Welcome to the friction trap. Every time you tie your shoes, you're running a live stress test on textile geometry. Let's talk knot topology. The standard bow isn't fashion. It's a calculated distribution of normal force. You're trading coefficient of friction for structural redundancy. Slip the angle by 3 degrees, instant latency in the hold. Now watch the material creep. Cotton absorbs moisture. Polyester sheds it. Both expand at different thermal rates. You tie it tight in July, untie it in January, and suddenly your knot has zero shear strength. That's not bad luck. That's material fatigue doing the math. And don't even get me started on Velcro. Hook and loop, please. That's a design choice failure. The hooks deform under cyclic loading. You lose hook engagement after 10,000 cycles. It's a lazy friction shortcut that screams skill issue. So why do we keep the bow? Because it forces cognitive engagement. An untied lace isn't a bug, it's a daily attention check. Your brain has to process structural integrity before your feet process pavement. Here's the bottleneck. Knots rely on static friction. Movement introduces dynamic variables. Sweat, dust, microabrasion. Each step grinds the fibers. The knot doesn't fail. It negotiates. And negotiation takes processing power. You think modern synthetics fix this? Wrong. Engineered polymers have higher tensile strength but lower surface roughness. They slide, they refuse to bite. You're literally fighting a lubricated geometry problem. Step back to 1995. Canvas sneakers, flat cotton laces, predictable friction curves. You tied them, they held. Now we're running nano-coated fibers through plastic eyelets. The system is overloaded. So what's the fix? You don't. You optimize the human layer. Treat the lace as a latency monitor. If it slips, your grip torque was insufficient. If it holds, your attention matrix is calibrated. It's a closed-loop control system. Moisture changes everything. Water acts as a boundary lubricant. It drops the friction coefficient by nearly 40%. Your knot goes from secure to slippery in under a minute. That's why puddles are the real enemy. And the eyelets, they're stress concentrators. Every pull concentrates load on a 2-millimeter radius. Metal fatigues, plastic creeps. The lace path becomes a structural liability. You're routing tension through a weak point on purpose. So next time your shoe comes undone, don't panic. Run the diagnostic. Check torque. Check fiber engagement. Check your own focus. The lace isn't broken. It's just telling you the system needs recalibration. Subscribe if you prefer friction over fasteners.